So here's problem number 1. It says below is a pedigree of a rare human skin disease. Yeah, this whole thing. And so basically the circle means female, the square means the male, and then if it's shaded in, it means that they're affected with the disease.
Okay.
And then, so inheritance of the disease by the 113 male right here from his father rules out what kind of inheritance. So there's 4 types. Just gonna write it here: autosomal, dominant.
And what's autosomal refer to?
Autosomal refers to basically any gene that's not sex linked, that's not linked to the other. Autosomal.
And what is a sex-linked gene?
Recessive. A sex-linked gene is a gene that's carried on the X chromosome of one of the parents.
Okay. Only the X?
Yes. And then X-linked. Dominant. And X-linked. Recessive. Okay, so an autosomal dominant would look like this. Say it's heterozygous.
Okay.
And so if the father was this and the offspring, the male, could inherit any combination of genes from both of the parents. So it's possible that the offspring could inherit the dominant gene from the father and then the recessive gene from the mother, and it'd still be affected.
Okay.
So we can't completely rule that out. And then autosomal recessive. Still, if the mother is recessive, she still wouldn't be a carrier of the disease if the disease is autosomal recessive, and the child could still inherit both recessive genes, and he would be affected too. For X-linked dominant, it'd be carried on the X chromosome. And the mother would not be able to have either of her X-linked genes be dominant because otherwise she'd be affected. And the son would have to inherit the Y chromosome from the father because all males have Y chromosomes. So he would have to have the recessive chromosome and therefore would not be able to be affected. So it rules out this one.
Okay.
Next is X-linked recessive. So if we assume the mother's heterozygous again, which is like a worst case scenario, then
what's another option?
The other option is that the mother would be homozygous dominant.
Okay.
And so if we assume that the mother's is heterozygous, then obviously again the male would have to inherit the Y chromosome from his father, and then he could still inherit this one from his mother. It's still possible, so he could still be affected in this case. So between all these, the only one it rules out is X-linked dominant.
Okay, great.
Okay. And then who in the pedigree has the same 4 chromosomes as the same Y chromosome as the 113 male, which is right here.
All right.
And so in this case, all of the males that are related to it will have the same chromosome, directly related. So this one, its father will pass it down. So that's 1, 2. Then as we go down, he's going to pass it down to 3, 2, because it has that as an offspring.
Okay.
And then these are females, so it won't pass down the Y chromosome. This one's unrelated. The next one is 3, 6, another male offspring. And then that's it from this row. Then
what does a row represent?
A row represents a generation. Okay. Yeah. So then 3, 2. This male will again reproduce, which is the only one that reproduces, which has the Y chromosome passed down. And then it goes to 4, 2 because these are all its other offspring are female, and then again it's passed on to another male. So those are the ones that it's related to.
Great.